Here's a snapshot of a Science Plus C unit. Let's start by observing a model. What are the parts, what are they doing, and what is changing over time? Notice that there's one red agent in a sea of blue. The population graph shows the number of red agents over time. And there's one variable called maximum wiggle angle. Next, we ask, how does this model work? And we can inspect the code that runs the simulation, but that may be too daunting at first. So we use a form called decoding by matching. In this form, there's some behaviors on the right, and on the left there is a box that can be moved and dragged to the corresponding code. In this way, a student can make connections between actions that are part of a scientific phenomena and the code that embodies that action. Here we've identified that moving with a chance of turning at each step takes place through this wiggle procedure. There's a right turn by a random amount, a left turn by a random amount, and then a small forward step. Next, we ask, in what way does this reflect what we know about the real world? Is this how people really move? We know in the real world, people are mostly staying at home now. So let's change the model so it reflects what we know. By commenting out the left turn, we can make the agents stay close to home. Let's see how this change impacts how the model runs. We can see how changing the agent's behavior impacts the overall spread of the disease. Furthermore, using a model like this, we can answer additional questions like, does everyone need to stay home, or only those who are infected? And what if people don't know if they're infected?